Hello friends, welcome to my channel. Let's have a look at problem 2510. Check if there is a path with equal number of zeros and ones. This video is a follow-up video for a previous video for the same problem. And in this video, we're going to share and explain a solution based on recursion with cache. First, I'll read through the problem statement, and then we do the analysis, and finally we share the code and the explanations. First, let's look at the problem statement. We are given a zero-indexed m by n binary matrix called grid. We can move from a cell either downwards or to the right. So return true if there is a path from the top left to the bottom right that visits an equal number of zeros and ones. So as it stated, so here we need to visit an equal number of zeros and ones. So here are two examples. So in the first example, so we have a 3x4 matrix, and the output or return is true. And in the picture, it marked a valid path. In this path, there are 3 zeros and 3 ones, so the number of zeros and ones are equal. So in the second example, the output is false. You can check that there's no way or no path in this grid with from the top left to the bottom right with equal number of zeros and ones. So with that said, let's also mention again the constraints. First, m and n are the number of rows and number of columns respectively, and they are bounded below by 2 and above by 100. So overall, the number of elements, that is m times n, is bounded by 10 to the power 4. Again, so the grid is a binary grid, meaning that so the element is either 0 or 1. So with that said, we are ready to look at the analysis. So in this video, we are going to provide a recursion solution. So here we are going to use cache. So essentially, it's a format of dynamic programming. So the idea is the following. So we are going to retrieve and store for each position RC or XY, if you like, the number of zeros and the number of ones. So actually, we are interested in their difference. In other words, the number of ones minus the number of zeros, or you can use the number of zeros minus the number of ones, right? So if this difference is 0, it means that there exists a path that starting from RC and ending at bottom right, that is m minus 1, n minus 1, with equal number of zeros and ones. So in implementation, so we move down or to the right and check the element at RC. If it is 1, so we add 1 to the difference. If it's a 0, so we add negative 1 to the 0, right? So this actually, in effect, means that we regard 1 as 1 and 0 as negative 1. Then we want to find a path which has path sum 0, right? So this is a way of understanding. So this problem can be solved verbosely following the problem statement with the help of cache technique. So as we mentioned, as we use cache in this video, essentially we are using a format of dynamic programming. So in this video, we are going to provide a recursion solution. And actually, in a previous video, we provided an iterative solution format based on traversal. So with that said, we are ready to write the code. So the code actually is not long. So first, let me make some preparation. So here I'm going to track the number of rows and the number of columns. So that is length of grid and length of grid and 0, right? And then next, so we're going to write the traversal hyperfunction. So hyperfunction. So in this, I'm going to define it as check. So let's see, check RCS. So this function will return. So if there is a path starting from RC and ending at the bottom right, and the pass sum is s. So the return will be Boolean, right? So this function, we're going to use decorator. So here I'm going to use cache, right? So here first, so let me do a check. So first the condition. So if r equals m or c equals n. In other words, it's outer bound. So this is the base condition or stop condition. So we're going to return false. Otherwise, so we're going to increment this difference or sum. You can regard s as sum. So if grade RC is 1, so we're going to increment by positive 1. Otherwise, so we're going to increment by negative 1, right? So this is the problem logic itself. And then we can, and next we can do the check if r equals m minus 1 and c equals n minus 1. And then we're going to return if this sum is 0 or not. Right. So if you compare with the previous video on the same problem, you can see this is actually in parallel. So next, so if nothing has returned, so we're going to return. So if we can have this two, r plus 1c and s, this means that we can have a downward path from rc to below, and also we can do r c plus 1 and s. So this is to the right, right? If one of these two conditions are true, so then it means that there is a path starting from rc and ending with with zero sum path. So or equal number of zeros using the interpretation, original interpretation. So with that said, so we finished the hyperfunction. So next, so we are going to use a decorator. So here we are going to use cache. So with that said, so next we are ready to do the return. So in order to explain two related methods with the cache decorator, so we're going to introduce a variable called result. So it's check. So we're going to check from 0 to 0. So this is the starting point, and we want the number of zeros and 1's to be the same. So here is 0. Or you can interpret the sum to be 0 if we interpret 0 as negative 1. And then we're going to return the result. So this is a solution to this problem. So let me first do a check. Yeah, this passes the first example. Now let's look at the generic case. Yeah, it passes all the test case. So that's about it for a solution to this problem. So here I would like to, the reason I introduced this one, because if we just want to do this problem, we can directly return this one, right? So we can just return check 0, 0, 0. And then let's comment out this, right? let's check. So here, the reason we introduce this this variable means that we want to explain two methods, to mention two methods. One is cache info. So you can let's print out this one. Print this cache info and return this result. So let's do a test. So so sorry, not this one. This is callable. So you have the cache information, or also you can clear out this cache information. So you can check cache clear. So let's check again. Yeah. So let's, if we comment this out, so let's do this check, and then let's submit. Yeah. So yeah. Anyway, so these two functions are the two functions we want to mention. So let me mention it again. So one is check cache info, right? This is one method. Another method is cache clear. So let me keep this one here, and I'm going to return this result, right? Okay, so yeah, so that's about it for this problem, and also it's the end of this video. So as we mentioned, so there's another video which is on the same problem but with an iterative depth first search format. So you can compare the two solution formats and digest more or come up with other formats of solutions to this same problem. So with that said, I guess that's about it for the video. Thank you.